Hello everyone, welcome to another class of CSAT. As you know that we have started the number system. The first session we have taken about number system in the last class. So now we are continuing our series for the number system. We have discussed in the last class. We have discussed what? We have discussed about the basic concept of number system, that is related to even number, odd number, prime number, natural number, what are whole numbers. Okay, what are integers? Tell me, what are integers? Okay, integers are the number which even can be a negative, it can be a zero, and can also be a positive number. So it will be on a number line. Okay. So we have also understood about the natural number. What are natural number? Natural number are the number which basically start from the one, like 1, 2, 3, 4, 5, 1 onwards. If we consider zero also, then it would be whole number. Okay. So it means it is like this. Just a second. So it would be a similar to. Let me take a screen to you people. See, this we have discussed. Okay. uh okay, so here we are, like in the last class we have discussed this thing. So we have taken if we are taking an like a number line. So in number line we have a 0, we have a 1, we have a 2, we have a 3, we have a 4, we have here -1, -2. So here's this minus and 0 and all this would be integer. If I consider from 0, then it would be a whole number. Okay. If I'm considering from 1, then it would be a natural number. Okay. We have also understood about the prime number. We have understood twin prime number. Twin prime number are the number which are between difference between the any prime number which can be a 2, like 3, 5, like 15, 17. Okay, 15, 17. 15 is not a prime number, but can be said like 11, 13. Okay. We can say like 11, 13. These are twin prime. The reason, because 13 minus 11 would be a 2. So if the difference between the two prime number is 2, so it would be a twin prime number. Okay, then we have understood about co-prime number. Co-prime number, okay, any number which like not able to divide each other. Okay. Then we have also studied about what? We have studied about uh, this composite number. Composite number are the number which have two factors, like other than, like basically can be said as a three factors. Okay. So basic, if any number have a two factor, it would be a prime number. More than the two factor, it would be it would be known as a composite number. So we have understood some basic concept related to like numbers. Okay, numbers in number systems. And then we move to a even plus odd. What can be even plus odd? Okay. Odd plus odd, what number can become? So we have also understood some basic like we have understood this. Okay. So when I used to say even plus odd, so even plus odd is going to be what? We have discussed this. Just a second. Okay. So even plus odd, when I'm saying even plus odd is going to be odd. Okay. When I'm saying even plus even is always been even. Even minus even is going to be even. Okay. Odd plus odd, even. Okay. Other we have a odd. If odd minus odd, then also odd. Okay. So we have discussed this some basic concept related to number system. In this class, what we'll do, we'll solve some question related to number system which has been asked in the examination, and later we'll move to solving other some questions which were asked in this examination only. Okay. And we'll also, what we'll do, we'll solve some question related to divisibility rule, and we'll also discuss divisibility rule again, because see, divisibility rule, there are so many questions asked in the examination. Okay. So we'll solve some divisibility rule question also. Okay. Okay, so here are the like first question for the discussion, and we'll be solving this question. Before starting with this question, just I'll revise for you. Just a second. When we are discussing about the representation of number, for example, I'm writing this number, so it can be written as what? It can be written as a, let's saying XYZ is a 3-digit number. If I'm saying let XYZ as a 3-digit number, so it can be said as like Z at the unit. Z is to be at unit place. Y is where? Y is at a 10 place. Okay. X is where? X at a 100 place. 100, 10 and unit place. So we have a 3-digit number XYZ, and it can be written as also, when I say 100, so at 100 can be multiplied with the X. Yes. Again Y. So can I write 10 into Y? Again in unit, can I write in unit as a 1? So like 1 with respect to Z. So what would be the 100x plus 10y plus z? So this can be the representation of numbers. Yes, this can be a representation of numbers. So when I'm saying like when we have a 3-digit number, so we can also represent like this also. So let's take an example. See, the discussion, the major aim of the solving the question in the class is your opening of your brains. Like you have to understand the each concept so that it can be easy for you to like while practicing. Okay. So let me take another example for more clarity. For more clarity. So for example, if I'm writing 153. Okay. So let me write. So what it can be said? Like one is multiply what? One at, tell me, three, where is three? Three is at a unit place, it is at a 10 place, and 1 is at what? It is at a 100 place. So can I write 100 as 100 into 1 plus 10? Why I'm taking 10? Because 5 is at a 10 place. So I can write 5 like 10 into 5 plus 1 into 3. So it would be 100 plus 50 plus 3. It would be a 150 plus 3. That is basically a 150. Okay, so that is the basic representation. So let's solve several questions on the basis of this. This question is a like a previous year question and asked in the examination. So we'll see what is asked. Consider the following sum: dot plus 1 dot plus 2 dot plus dot 3 plus dot 1 plus 2 1 dot. In the above sum, dot stand for what? So in this question, they are asking what do you mean by dot? So if you are like the another one, the one way which you can do, you can just put every option. Okay, like 6, 8. So you can write like this also. For example, you're putting 4 plus 1 plus 4 plus 2 plus 4 plus 4 3 plus 4 1, then 2 1 4. So if you solve this, you will then able to see whether it is coming or not. Then you have to put every option. So it becomes difficult to like this can be also one way, a shorter way, but you need a time because you have to put every option and you have to add. But the major way that how you can have to solve this type of question, this question is a type of a representation of numbers. Okay, so can I write this like let let dot be x? Can I write like this? So let me put here x plus 1x plus 2x plus x3 plus x1 2 1x. Okay, so now let like this is x, so x is what? It is a unit place, nothing to worry. So here 1x, so can I write, see this is at a 10 place, this is a unit place, so can I in place of 1 like 10 into 1 plus x into 1. Okay, plus in place of 2x, can I write like 10 into 2. Okay, plus x into 1. Okay, can I write here like 10 into x, 3 into 1. Okay, plus here we have x, so what can we write? Here we can write 10 into x plus 1 into 1 equal to what? 20 into like, sorry, here we don't have to write 20, but we can write 2. So we have to write 2 into 100 plus 1 into 10 plus x into 1. See here I have tried like to simplify more, but in the next question if there is a question, we'll be like skipping some steps so that it can be not to be like spoon feeding like. Okay, so here what we can write, x plus 10 into 1, it would be what? 10 plus x into 1, x plus 10 into 2, 20, like 20 plus x, 10x plus 3 plus 10x plus 1 equal to what? 200 plus 10 plus x. Okay, this can be written. So let add this type. So as we know that digit should be added digit with the digit and the variable should be added with the variable. So okay, so let's like first we take the like variable. So here we'll take x like 1x, 2x, 3x. Then we have 13, like 13x, like 10 and 3 would be 13x, and then we have a 10x, that is 23x. So can I write as a 23x? Okay. Then what we'll do, I will add the digit. So that is what, 10, 10, 20, 30, 33 plus 1, 34, 23. Just a second, I'll write this side. So plus 34. Okay, so it would be what, 210 plus x. So let's like 23x minus x, like if x would become this side, it would be 23x minus x, and then 210 minus 34. Okay, so let's see. So 23 minus 23x minus that is 22x. Okay, and then we have a 210 minus 34, so it would be what, 10 here, 10, and like 24, like 176. So x would be what, x would be 176 divided by x, sorry, 22. So 22 should divide also. So 22 ones are 22. Okay, or 22 is a 44. You can divide here also, like however we like we know, like 22 into 8 we have 176. Okay, so x would be what, x would be 8. Okay, so here answer would be your option D, that is 8. Okay, so see, uh, the basic fact of the preparation for the CSAT is you have to understand how this question to be solved in the examination, because here we don't have to solve all the question. We have discussed this also earlier. See, out of 80 question, we have to just find those 45 to 50 question in the real examination, so that we solve those question, and out of those at least we can get through like 38, 39 question to be correct. Okay, so that we can easily get through the examination. However, we don't have to be like get the shortcut key. We have to use SSC formulas. We have to do banking formula. No, because this examination for the CSAT student require. Just a second. Let me take a look. Okay. So for CSAT student, it require what? It require uh, patience. It require like not it require analytical skill. Okay, not in the shortcut formulas. So we have come through, like the answer would be 8. Okay, however, see, you might think that it require a lot of time to write this, but it is not like, if you want, once you used to become, you can instead of multiplying one with the, like it is at a 10 place, so we can, here we can multiply 1 with the 10, we can directly write 10. Okay, so it, we can also skip some steps. Okay, so we'll see in the next question also. Let's have a let's solve another question. Okay, so see, however, one thing is there, like while solving question, I'm putting I'm just doing a spoon feeding for you, because it is the initial classes and we want a confidence. We want a confidence, so that are we able to solve those questions? Yes. Okay. So now have, like, let's take another question. X plus 1x plus 5x plus xx plus x1 1xxx. It is there. Okay. So can I write this again as what? This symbol as x. So I can write x. Okay, let me take. So can I write x plus 1x plus 5x plus xx plus x1 1xx. Tell me, here it is x. Here would be what? 10 into 1. So can I write 10? Yes. Here would be what? X into 1 again. Here would be 5 into 10, 50. Here what? X. Very good, very good. Yes, xx. We have what? 10 into x, that is 10x. Then we have x. Then here we what? We have 10 into x. Okay, I can write 10 into x also. but I would write here 10x because now we have become used to 10x plus what? Plus 1 equal to, it is a 100 place, it is a 10 place, it is a unit place. So I can write 100, yes, 100 into 1, okay. Now I can write here in place of x, what will write? 10x, very good. And at last we have x, okay. Now let's add this x, 2x, 3x, 13x, 14x, 14 plus 10, that is 24x, okay. So here we have a 24x, 10x, 50, 60x, 61x, not x, 61, okay. So 100 plus 10, like it would be what? 100 plus 11x, okay. So let's like, now the variable would be coming this side and the digit would be coming that side. So 24x minus 11x equal to what? It would be 100 minus 61, okay. So here would be what? 24 minus 11 would be 13x, 100 minus 61, like 39, okay. So here would be what? X would be 39 divided by 13, which is, your answer would be what? Your answer is option B, okay. See, like these are very easy type of question. Usually, like we have seen in the UPSC, even these questions are latest questions. But we want to solve. If you start solving this type of question, it becomes used to, not a big deal to solve. Okay, let's take one more question. So here the question is asking x and y are natural numbers. See, now we have understood what a natural number. The number will start from 1, 2, 3, 4, but start from 1 onwards. Other than 1. So they are asking x and y are natural number, but other than 1. It means starting from 2. And y is greater than x. Y is always greater than x. So if we are taking x as 2, 3, 4, 5, 6 or any number from 2. If y is greater than x, it means what? Y would be 3, 4, 5, 6. Okay. Which of the following can represent the largest number? Which of the following? Like they have given a 4 option and we have to take which can be a largest number. Okay. So can we take x as a 2 and y as a 3? We have to take this because these are preconditions. Okay. Now what we'll do? We'll take these 4 options and we'll put in that. Okay. So let's take option A, x by 1. So if we multiply 2 into 3, it is going to be a 6. Okay. If we'll like even into odd is even, that is another. Okay. We'll take a B option, x by y. So again 2 divided by 3, we know 0.67. Rational number concept, rational, irrational. Let's take C. Let's take C. C is what saying? Y by x. Okay. Y by x. So y by x is what? 3 divided by 2 is going to be 1.5. Yes. 3 divided by 1.5. And D is what? D is x plus y divided by x into y. So x plus y is what? 2 plus 3 x into y is going to be 6. So 5 by 6. 5 by 6 is nothing but 6 is a 36, 6 is a 42, 6 8 is a 48. Okay. So it would be 60.8. 48. 2, and then we have a 6 is a 18. So it's going to be continuous. So which of the following is like represent the largest number? It is a option A. This is x into y, which is 2 into 3 is going to be a 6. See, the answer is 6. Okay, the answer is 6. The answer is 6, and which means option A, which is the product. However, it can also be understood like this: if the product, if you are multiplying any number, multiplication is always a maximum. Okay, multiplication is always a maximum. For like, let me give you more options. For in case if B would be x plus y only, so can it would be maximum? No. If the condition x minus y, like if there is option B or C as x minus y, then can it be maximum or largest? No. If I'll say like Even if dividing, if x divided by y, if I'm taking like this, can it would be a maximum? No. So the maximum can be only in case of product. If you are multiplying two numbers, then it can be maximum. Okay, so we have understood this concept also. So let's move to another question. I hope you understand. Okay, the basic idea of the taking classes for CSAT is like if you have a little much practice, at least some practice, and if you solve the previous year question, you have a mindset for the preparation, you can definitely make it through the examination. For CSAT, we just require a calm mindset, a patience, and a like aptitude level solving skill. Okay, let's move to another question. Okay, now this is another question which says like seven, like 7 plus 9 plus something is equal to 8. Okay, then 9 plus 11 plus 30 equal to 5. 11 plus 17 plus 21 equal to 13. Okay, 23 plus 4 plus 15 equal to what? Equal to, we have to find. Okay, so this is your question. See, this is basically, if you see, if you will write this, but this is again a sort question of like based on the number only, but it is your analytical mindset they want to check. Okay, so let me write this question first. So 7 plus we have 9 plus 10 equal to 8. So they are adding something, but it is becoming very less. It is becoming very less. 9 plus 11 plus 30 equal to what? Equal to 5. Then we are taking, okay, then we are taking 11 plus 17 plus 21 equal to 30. So now we have to find what? We have to find 23 plus 4 plus 15 would be what? That we have to find. So let's see. 7 plus 9 what? I'll write for you people. Okay, let's add 10 plus 9, 19, 19 plus 7, 26. So they have written 26 as 8. Okay, they have written 26 as 8. Now we'll add, right, 9 plus 11 plus 30. So 9 1 10, 3 1 4, 1 5. So they have written 50 as 5. Okay, let me take like 11 plus 17 plus 21. 7 8 9 into 4 49. Okay, so 1 8. Okay, now 49. So they have written 49 as 30. So now see, if we say like 5 is repeating, like 5 is there, but what about 0? So might be they have taken 5 into 10 15, so it might be multiplied with a 10, but here not. Okay, and if you multiplying 13, 13 3 is 39, but not 49, there is no chances of 49. However, in our mind it can be like, it can be instinctively can come, or like if we are taking 26, so 2 plus 6 is going to be 8. Yes, it is showing something. If I'm taking 5 plus 0, yes, we have 5. Yes, we are taking 4 plus 9 is what? 30. Yes, we cracked it. Okay, so see, now you can think it is easy for you to, when we are solving in the like classroom this type of question, but there your mind should be like alarming. It should be like you have to focus, like if you are seeing like 2 plus 6 or 26, how 26 can be 8? How 26 can be 8? Whether it be divided, but 26 is not divided by 8. Okay, so I'm saying it like 24. So 24 can be like our, if there will 28, like 24. So can be said it can be divided, like it can be divisible anywhere, like any other concept. But we are saying yes, like we are able to understand like 2 plus 6. is going to be somewhere we have addition concept. Okay, 5 plus 0 we have another concept of addition. 49 if I'll say 4 plus 9. So we have cracked it, like it is adding the, we have taken numbers and we are adding at last. Okay, so here we can like say 23 plus 4 plus 15. 4 plus 3 7, 7 plus 5 12. Okay, 2 1 3 4 40 42. So 42 can be written as 4 plus 2. It's going to be a 6. Your answer would be what? Your answer would be option A. That is 6. That is 6. Okay. So see, this is very easy question. Okay. If you start solving in the examination, it might feel like how it can be solved, But you have a little bit practice and presence of mind. This type of question can be solved in the real examination. Okay. Definitely for sure. Okay. Okay. So, we'll take a small 30-second break, not to be more than 30 precisely. And now, what you will do in this 30 seconds, you just start what you have written in the pages, just see a glimpse, and then we'll move ahead. Okay. While watching this video, make sure that you at least watch in a one go and not take a break in a between. A small can be taken at 30-20 seconds, but do not watch a video in a like in a 15 minute, you are watching again in 10 minutes, so it's not going to be a benefit for you. Okay, just take a 20-second break. Sorry. Okay, so now we have completed some basic concept of number system. Now we have some basic concept of number system. Now we are going to apply the concept of number system to a divisibility rules. However, in the last class, like I have given you a glimpse of divisibility rules. Now we are going to be cover the divisibility rules and will also solve some question of divisibility rules. Okay, so here divisibility rules. So divisibility, in the divisibility rules, we have several rules for the divisible, like 2, 3, 4, 6, 5, 2, 3, 4, 5, 6, 7, 8, 9, and 11. Okay. So tell me if any number would be there. For example, 100. So can how would I know this 100 is divided by which numbers? Okay. Can it would be divided by 1? Yes, definitely for sure. 2, yes, you know. If you multiply 2 into 25 is going to be a 3, you are not aware now, like whether it would be divided or not. 4, you might have an idea. 5, you again have that. 6, you are not knowing. 7, you are not knowing. 8, you are not knowing. 9, you are not knowing. 10, yes, definitely. So, like, if any number would be given, so you can like by seeing its last digit, that is its unit place, or by there is some method you can understand whether this number is divided by 3, 2, 4, 5, 6 or not. Okay, so there are several methods you can see, and okay, that is the discussion of the topic. So let me take you the divisibles. So if we consider 2, so for 2 we have what? 0, 2, 4, 6, 8. So these are some numbers which are the divisible for. So if at any number, like in case we have a 132, we have a 100, or we have a 12, if at any number, not any number is given, or whether it is a 2-digit number, whether it is a 1-digit number, we have a 3-digit number, 4-digit number, but we have to just see the last digit. If at the last digit we have a 0, 2, 4, 6, 8, then it is definitely going to be divided by 2. Okay, so now if we consider the 3 condition, so the sum of the digits should be divisible by 3. It means what? In case of 3, all the sums should be added, and if the sum is divided by 3, then it is a divisible of 3. For example, here we have taken 4, 6, 4, 7, 6, 4. So whether this number is divided by 3 or not. So now you have to, like, this is a tough task. So what we'll do, we'll add 4 plus 7 plus 6 plus 4. 6 plus 4 10, 10 plus 7 17, 17 plus 4 21, and 21 is definitely divided by 3 because 3 7 is 21. Now we can be saying 3 is a, what is 3 is a, this number is going to be divided by 3. So 4764 is definitely divided by a 3. Okay, just a second. Okay, so I can be saying that 414, like 4764 can be divided by 3. Okay. Let me take another question. Like, let me take another question. For 3, let me give you some more question for practice also. Okay, so for 3 you take one, like, let me take you with this question. So if I'm taking 5 1 2, what is it? 5 plus 1 6, 6 plus 2 8. So it is not divided by 3. Okay, it is not divided by 3. So it means what? It, the 5 and 2 is not going to be divided by 3. It's not going to be divided by 3. Okay, so we got to know about 3. For 3 we have to divide the whole number. Like, if we add the all number, if it is divided by 3, then it is divided by 3. Okay, for 4 we have last two digit number should be divided by 4. It is divisible by 4. So for example, here it is, they have given example 1924. So it is last two digit, it is divided by 4. The number is divided by 4. Yes. Okay, for example, if I'm taking 52620, tell me, would this number would be divided by 4? You have to check the last two digit number. Okay, the last two digit number. Okay, so if the last two digit 4 5 are 20, yes, it would be divided by 4. Basic, simple. Make it simple. Okay, now go for, sorry, now we'll take a 5. The condition of 5 is very simple because 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20. So for every 5, we are able to give 5 twos are 10, 5 threes are 15, 5 fours are 20. If you take last digit, is always be 0 5. Is always be 0 and 5. So if 0 and 5 would be there, so there would be a, that last two digit is a 0 and 5. So it would be always divided by 5. Okay. For 6, the number is divisible by 2 or 3. So it's simple. If any number it is divided by 2 and it is also divided by 3, then it definitely is also divided by 6. Okay, if any number which is divided by 2 also by 3 is also divided by 6. Okay, for example, if I'll say 66, let's take 66. So 66 is divided by 2. Yes, we get 22. Whether it divided by 3, we 22. So if any number divided by 2 or 3 both, then it also divided by 6. So it can be said like 66 is divided by 6. It's simple. Okay, now take like, we'll wait for 7, but we'll move to 8. Okay, so for 8 we have a basic simple rule similar as we have taken for 4. So 4, in the case of 4, we used to take only two digit number, the last two digit number. Now we take last three digit number. So if we have a 8, we'll take a last three digit number. But if we have to consider the divisibility of 4. So what we'll do, we'll take only last two digit number. Okay, so in case now, like, we are taking 1320. So here we have to take last three digit number. So we know, like, 320, if we divide with the 4, 4 8 is 32, and we know 0. So we know 4 into 80 is going to be a 320. Okay, so in case of 8, we have to take the last three digit number. For example, let me take one example of 4764 512. This I'll take for you. Okay. So tell me now if whether this number is divided by 4 or not. Tell me 4. So you can say, sir, for 4 we'll take last two digit number. For 8 we'll take last three digit number. So for 4, yes, it is 12. It is going to divide by 4. For 8 we'll see, we'll add like 5 1 2 we'll see, and we'll check, we'll divide 4. Okay. So 4 ones of 4, we'll take 4 here and 1 again, 1 4 3 is 12, no, 4 2 is 8. Okay, we can take it 332. Okay, 4 is 32. So yes, it is going to be divided by 8. Okay, now we'll see conditions for 9. 9 is again simple, similar to 3. We have to check by adding all the digit. Okay, we have to check by adding all the digit. So for in case we have a 288, we will add 2 plus 8 plus 8, 10, 18. So 18 is going to be divided by 9. Yes, but here we have to check this whether the number is after adding. For in case of 3, if we add all the digit, it should be divided by 3. So yes, the number is divided by 3. If by adding all the digit is like able to divide by the 9, then the whole number is divided by 9. Okay, and 10 is very simple, it's just 0. 10 on the 10, 10, 10. So in the last digit, for example 1000, for example 950, if we have a 0 at the last digit, it would be what? It would be a 0. So if the last digit at the last digit we have a 0, so yes, definitely is going to be divided. It is definitely going to be a divide. Okay. So like, let me make you clear with the 7 also. See, let me take you one more. We have a 11, we have a 12, and we have 13. Then there are certain like a 10 till 10 can be understandable, but not needed other. But 12 I can write for you. If any number divided by what? 3 or 4, then it is going to be divided by 12 also, as condition of 6. So for example, I'm saying we'll take 24. So yes, 24 is divided by 3. Yes, it is divided by 4. Yes. So whether it is divided by 12? Yes. Let me take 36. Divided by 3? Yes. Divided by 4? 4 9 is 36. Whether it would be divided by 12? Whether it would be divided? Yes. Okay. So yes. But let me take you the condition with this 7, 11, and 13. These three. See, in these number there is a rule which says what you have to do. Don't consider this one. I'll make you see. It is written that double the last digit and subtract it from the rest of the number, and the answer is divisible by 7. No, no. This would be difficult to solve in the real examination. I'm just putting my extra trick here, which I would be adding here. So you just put down in your notebook that this is extra trick given by me. What you have to do, whether we have to check 7, whether we have to check 11 or 13, at all three condition. For example, let me take a one question for you. 489, 449, 8518. Just a second. 8518. So now tell me whether this number would be divided by 7 or not. Whether this number would be divided by 7 or not. Let me write this at a different page. Let me write here only. Okay, I'll write, then we'll erase. Okay, so like write this again. 489, 449, 8518, 8518. We are going to check about 7. How the rule of 7 follows. So the rule of 7 says we have to make pairs of 3 digit. We have to make a pair of 3 digit. So we'll do 518 one pair, 498 another pair, 894 another pair, and this another pair. So we have to take a pair from the left side, not right side. Again, I'm saying we have to take a pair from the left side, a three-digit pair. So what we'll do, we'll add those pair. 8518. This is group A, group 1. This is a group 1. This is group 2. This is a group 2. So group 1 a different side, group 2 a different side. Okay. So now what we'll do? A 518, a group 1, this one, 894. Just a second. 894. So 8 4 12, 9 1 10, 11, 8 5 13, 1 40, 1 4 1 2. Okay. So 1 4 1 2. Here what we'll do? 4 4 9 group 2. This is a condition of group 1. This is a group 2. 4 4 9 plus 4. So 9 4 30, 5 4 50. Just a second. Okay. 498 actually. This we have taken. Okay, just a second. 4 4 9 4, sorry, 498. This is your 498 plus 4. So 8 4 12, 4 1, like 4 4 it will get 5, 452. Okay, so you are getting 452. 498. Sorry, just a second. Not that. Okay, see here. Actually, we have 498 and we have to add this with 4. So 8 plus 4 12, 9, that is 0. Like we'll add, take a carry here. Okay, so here we have a 502. So we have a 502 here and we have a 1412. So 1412 and we have a, so always remember minus group 1 minus 2. So take group 1 and minus take group 2. So 1412 minus 502 220, like we'll take 10 here, 10 minus 1. Okay, so we have 40, 14 minus 5, 9. So 910, whether it is divided by 7 or not. If it is divided by 7, yes, then the number is divided by 7. If this number is divided by 11, then it is also divided by 11. And if this number divided by 13, then it means that this number is going to be divided by 13. Okay, so in all three conditions, it will be divided by. So in case of 7, in case of 11, and in case of 13, we have to make a pair. We have to make a pair from the left hand side, and we have to take a three-digit number. We'll add group 1, we'll add group 2. Okay. Then we'll difference, add group 1 minus group 2. Then if the number is the number after difference, the number which come after difference, if the number divided by 7, then yes. If number divided by 11, then yes. If divided by 13, then yes. So if in any, like if in examination you will get, so consider this 7, 11 and 13 are different pair or different group. What I have told for 12, I have for case of 12, I have told you for case of 12, it should also be divided by 4 and 3. Okay. So hope you have understood this. Okay. You can take a screenshot also and you can write in your notebook. Okay. So you just, if you start writing in your notebook, it will be also easy. Take a screenshot if you need it. Okay. So finally, we have completed the divisibility rules, divisibility patterns. Now we'll see some couple of questions that has been asked in the examination, and we'll see how the divisibility rules concept asked in the examination. Okay. Okay. So just give me a 10 seconds. So let's start with the question. So here the first question which asked in the examination, which was two statements are given below. Okay, the two statements are given by the two conclusion. So I have already told we have a data sufficiency, data insufficiency questions. So this can be also considered as a data sufficiency plus insufficiency type of questions. But the core concept is what? It is a divisibility based question. Okay, the statement is saying all the numbers are divisible by 2. We have all numbers, and the statement 1 say we like statement 1 we have all the numbers that all the number is divided by 2 and all the number is also divided by 3. So okay, so here we have a group and all the number are divided by 3, it is also divided by 2. Okay, this is second. So we all the we have a club like statement 1 the all the number is divided by 2 and all the number are divided by 3. So tell me what can be the conclusion to be, what can the inference would be taken. So the inference is what? The all number are divisible by 6. Yes, we do. For 6 we have for 6 we have what? For 6 we have number would be divided by 2 as well as a 3. So number would be divided by 2 as well as a 3. Okay, so if the number divided by 2 as well as a 3, then it is also going to be divided by 6. All the number is divisible by 4. Tell me, would all the number would be divided by 4, whether it will be possible or not. Let's take a condition. For example, the number which are divisible by 2 are what? Is definitely 2, 4. Let's take a 2 condition. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, or 24. Okay, so for 3 we have 3, 6, 9, 12. Okay, 12, 15, 18, 21, 24, 27, 30. So let's take in the case of first statement conclusion, what is saying all the number are divisible by 6. So if we are like, let me take any number. For in case I am taking this, I am taking 12. So 12 is definitely going to divide by what? 2, yes, 3, yes, and 6 also. Okay, so we don't have to take all the number like 2, 4, 6 all number. If I'm taking 12, so yes, 12 is going to be definitely divided by 2, definitely by 3, and definitely by 6 also. Okay, but if I'm taking like, let me consider this for in case of 4. Okay, for 4. So if I'm taking 4 also, like for this I have to write also the table of 6 and 4. Okay, so let me write with the 4. So 4, 8, 12, 16, 20, 24 we'll write it. And with respect to 6 also I have to write 6, 12, 18, 24. So here if I am taking 12, for in case I am taking 12, so yes, the 12 can be can be divided by 2, can also be divided by 3, and it also come in the 6 table. Yes, but in okay, but 4 also be 4 in 12 also coming in 4 table also. Okay, 4 also coming in 4 table also. And when I am taking in the case of 24, okay, when I am taking case of 24, yes, 24 is also coming here. 24 is also coming here. Okay, 24 also is coming here, and 24 also is coming here. Okay, so it can be said like, so even like number is divided by in case of 4 also, 6 also. But let take 18. 18 is divided by 2, yes, definitely. 3, yes. 18 is also divided by 6, but not in case of 4. That is why we'll say the conclusion 2 does not follow, but the conclusion 1 follows. Okay, the conclusion 1 follows. See, I have tried to elaborate as much I can this question, but see, this is a basic, this is a foundation. However, when we used to with this question, you can definitely get through this question. This would be very easy for you later. Okay, so let's move to another question. However, make sure again, like I'm writing here, for 6, the rule is what? 2 and 3. If any number divided by 2 as well as 3, divisible by 2 as well as 3 is going to also be divisible by 6. For in case of 12, if any number divided by 3 or 4, then it's definitely going to divide by 12. Okay, why? What are the reason? Because 2 3s are 6 and 3 4s are 12. This is what? This is, we are taking LCM. If we take LCM for any number, yes, definitely also divide by another number also. So we have taken the divisibility for 2, that is 2 3s are 6, 3 4s are 12. And if we consider for 6 12 also, then this is definitely going to be. Okay. It is definitely going to be same. So now we'll move to another question. I hope you understand this question. Okay. This is my favorite question. Like we have seen this in 2020, I think. Okay, and this is my favorite question. So let's solve. Okay, take a 5 second. Let you read this question and also read for you. Okay, so what this question is saying: how many 5-digit number? How many 5-digit prime number? Everybody knowing prime number. Which is the smallest prime number? 2. One is neither prime nor composite. Okay, which is the smallest composite number? 4. Because 2, 3 and 1, everybody have a, like 2 3 have a 2 factors and 1 has a 1 factor. Okay, so any number which has a more than 2 factors is going to be a composite number. So how many 5-digit composite number can be obtained by using all the digit 3 4 5 6 without repetition of digit? Without repetition of digit. See, now the people like the from engineering background students, they will definitely go for a permutation combination. But before taking a permutation combination, just see what the question is saying. Let's see. If this like how many 5-digit prime number can be obtained by 1, 2, 3, 4, 5. So they are saying if you have a 5 numbers, how many 5-digit prime number can be obtained by using all the digits without repetition of the digit. We don't have to repeat this word. Okay, so if I'm writing 1 2 3 4 5, so tell me whether this is a prime number or not. So at last, if there is a 5, yes, it can be said as a, this is a, like this can be like 1 2 3 4 5 a prime number. Okay, we don't have to repeat the digit. Okay, without repetition of digit. So you cannot, like in place of 5 you can write 1. You cannot, because 1 cannot be repeated again as a 1. So if we consider, okay, we can also write this also 5 4 3 2 1. Okay, so okay, can also be write this like I can take 4 3 4 3 2 1 5. Anyway, like I can arrange by any way. So how many 5-digit number? How many, like how many 5-digit number can be found which can be a prime number? So tell me what is the basic rule of prime number? Prime number cannot be divided. Yes. For example, when we consider 3, it cannot be divided again. 5, 7. Why I'm not taking 9? Because it comes in 9 table. It comes like in 3 table. The basic rule of prime number says a prime number divided by 1 and by itself. So if let me consider this, if we're taking any number, so would be one. If let me add, because if you want to check whether it is divided by any number or not, I know it can be divided by 1 and it can be divided by this whole 5 digit number. This like 54321 is going to be divided by 1 and it also divided by 54321. So these are two factors. Okay. Can I check if I want to check whether it is also divided by 2, 3, 4, 5? If it can be divided by one more factor instead of 1 and this the whole itself, if divided by one more factor, then it is not a prime number. Okay. If it is not divided, then it is a prime number. Okay. So for in case, let me check with the 3. Let me take this one. 5 plus 4 plus 3 plus 2 plus 1. Why I am adding? Because I want to check whether this number is divided by any number or not. So let me check for 3, because the 3 is very easy. For 3, just add 5 plus 4, 9, 9 plus 3, 9 plus 3, 12, 12 plus 2, 14, 14 plus 2, 15. So it is 15. And we know 15 is divided by 3. So it means what? Whether I would be making 5, 4, 3, 2, 1 or 1, 2, 3, 4, 5 or 4, 3, 2, 1, 5 or any arrangement can be made with this number without repetition. So the adding any number, adding this number is always going to be a what? A number which can be divided by 3. So basically this, if I can make any arrangement of this number, there is definitely it can be made by what? It can be divided by 3. And if in the case it would be divided by 3, and if the case it would be divided by 3, it means what? This is not a prime number, because a prime number divided by 1 and itself. If it can be divided by 3 also, then it means it is not a prime number. So if any arrangement can be made and we are able to divide by the 3, it can be said that no, it can be said, it can be said no prime number can be formed. Why I am saying no prime number can be formed? Because so it would be a 0. Have you got it? You got it? Because if we made any number 5, 4, 3, 2, 1, whether 4, 3, 2, 1, 5, any arrangement can be made. But it can be divided by 1. Yes, it can be divided by that arrangement, that is 4, 3, 2, 1, 5, 5, 4. Any it can be, yes, it can be. That is a basic prime. Yes, it can be a prime number. But if the number has a more than 2 factors, then it is not a prime number. For example, why I am not taking 9 as a prime number? Because it come in 3, it come in 1 and it come in 9. So it has a more than 2 factors. So it is not a prime number. So here also, if I make any arrangement and if it is divided by itself, it is divided by 1 and also divided by 3 here. So no prime number can be formed by using this digit. Okay. However, in question, if there is without repetition, with repetition, so with repetition we can change like 1, we can put 1, we can put 3. So it can be an answer. It can be a way to solve the answer. Okay. So we have taken. Okay. So we have taken almost today we have taken a lot, we have taken about representation of number. We have studied about representation of number. We have also studied about the divisibility rules, and we have solved questions, like we have solved 2 questions, 3 questions also on divisibility rules. Okay, that was the ask in examination. In the further classes, we'll utilize how the divisibility rules can be utilized in the solving another questions of UPSC. Okay, so we'll meet for the next class. Okay, we'll meet for the next class. Hope you have understood. Okay, solve practicing the question at home, and we'll meet in the next class. Thank you. Have a good day.